Hello, hi. So, in some of my previous posts, I might have mentioned that you could easily break down complex data structures and understand it easily step by step. Even in my programs, I would have, about my program, I would have said I will help you understand each data structure on how to break down and study. So it might differ for individual data structure, but I tried something, tried to come up with something generic, a generic rule of how to break down a data structure, an algorithm, a problem, and everything. We'll see one by one, and for now in this video, we'll see how to break down an individual data structure into several parts and understand it. So every data structure will have a structure and you could do a certain set of operations in it. So the first step, okay, before going to the first step, I would say that there are several steps until which, up until this step, you need not even touch the code. So all of these steps you could just do it visually and logically, and you could understand, and most of the core concepts you will be able to grasp, and your foundation will be foundation will be set, and coding will just be a very minor step after that. So first step, try to visualize the structure. If it is a stack, if it is a queue, if it is a heap, how does it look like visually, and try to understand each of the operations, like pop, push, enqueue, dequeue, or anything. How does it happen in visual way? So what you could also try is, so if this is a heap, it's extract min, you try doing it, take examples and see if you're given an example at a particular stage, you apply an operations, see if you're able to figure out what is the output that will happen next. What will be the resultant structure after that operation happens. For some complex data structures, you might have to do this, a different exercise where you take a different random example or a wrong example. You could probably use ChatGPT to generate and give you wrong examples, and then try to see if that is the data structure or not. For example, is this a tree? For example, is this a heap? If this is not, why is this not a heap and why is this not a tree? Then you will actually understand, some core feature of that data structure and how it applies. For complex data structures, this might matter when there is this is a very simple random example, but when you take more complex examples, you should be able to understand what is the key difference that makes the data structure what it is. And then you could try to understand what is the one core usage of the data structure. Why does it exist? What does it try to solve? You may not be able to figure out when you're going through it initially, but try to have a rough idea. It might be given in the material that you're using. So for example, if it is a heap, it does extract min and of an operation, so it simplifies getting min and max. So have a rough idea of what that core usage is, and with just this core usage and visualization, everything, you will still be able to do the analysis part. Like I discussed, if it is a heap, you could do the extract min and O of one operation. So you could, for each operation, you could try to do the analysis just from the visual. Is it an O of 1? Is it an O of n? And then try to understand that. So many data structures might have variants. For example, a linked list might have a circular variant. For a graph, it might be a directed or undirected variant. So try to understand that also visually, and then we'll go to implementation part. Now also we are not going to touch the code. So for example, stack could be implemented using an array, using a linked list. Try to understand how that is happening just by visuals. For example, graph could be a matrix, it could be an adjacency list. So try to understand its implementation visually. So this is like, outer level of abstraction of what the structure is and what the operation is. This is one more level deeper where you get into the implementation, but here also it's the second level of abstraction. You're just understanding it visually. Once you understand all of this, code is just one jump from this implementation. So if you have, basic coding skills prior, you might even be able to come up with the code for the internal implementation by yourself. You don't have to try it for every data structure, but you could, if you have time, you could actually try and implement it by yourself, or just go through the code and see if you're able to understand. And mostly in interviews, we'll not be using the internal implementation ourselves, we'll be using the libraries. So you would have to know what class exists in your language of choice. In that class, what are the methods available and what is the complexity of each method, and understand the analysis of it. So this is how you would break down and understand each of the data structure, from the visual to the variance to the implementation and to the code and libraries, and then we could move on to the problem patterns and problems, which is a different category. Bye.